Hi, I'm Bob Dopkin, Vice President and CTO at Linear Technology, and I want to talk about one of the members of our LDO Plus family. The LT3086 is a high-performance, low-dropout LDO Plus. As well as regulate, it has monitor and control functions built in to provide feedback to the system when it's being used. It'll provide up to 2.1 amps of output current. We have cable drop compensation, so it will compensate for drops between the regulator and the load. These devices can be paralleled, and we have a built-in power good feature. The architecture of the LT3086 is different from most other regulators. It has a current source reference, and the current source through a single resistor sets the output voltage. The regulator loop regulates the bottom of the current source resistor to 0.4 volts. So the output is 50 microamps times the R set plus 0.4 volts. By using a current source as our reference, we get constant loop gain independent of output voltage, so we have better regulation at high voltages and better transient response. We have a current monitor output, which will also control the current limit. When this pin reaches 0.8 volts, the device goes into current limit. So we have a current proportional to the output flowing through resistor to ground. Our current through the monitor resistor is I out divided by 1,000. When the voltage at this point reaches 0.8, we current limit. So if you want a current limit at a low current, you make this a high value resistor. If you want a fairly high current, this becomes a lower value resistor. So you can monitor as well as control the output current of the device. We can control the thermal limit as well. The thermal limit works slightly differently in that we remove the drive from the output transistor when the thermal monitor pin has 100 microamps of load on it. Internally, we have a voltage output at 10 millivolts per degree at this point. So we monitor the current drawn from the device to ground, and when we pull 100 microamps out of it, that's when we shut the device off. So for example, if I want to limit the temperature of this device to 125 degrees C, which is lower than the built-in thermal limit of 165, I put a 12.4K resistor here. When the output pin reaches 1.25 volts, I've got 100 microamps through this external resistor, and that 100 microamps triggers the internal circuitry to turn off the power device. And there's a few degrees of hysteresis in this. And we have our output current monitor as well. These devices are easy to parallel. They use a master-slave method of paralleling where the slave is forced to carry the same current as the master. To get this system to work, we have to have matched resistors on our current monitor point. And we take our current monitor point here on our master, we tie it to the track pin on the slave. This forces the slave to operate at the same current as the master. So whatever our load current is, we split it in two, and half of it goes to each regulator. Since this is a voltage point, we can tie several regulators in parallel to get even higher output currents. And they all track because of the way the track pin works. So it's easy to parallel two or more regulators to go for high currents or to spread the heat around the PC board. This is a full-featured regulator with current monitoring and control, with temperature monitoring, no control on it. We have power good, and we have cable drop compensation. If we have a load that's remote from the regulator and want to make sure that the load voltage stays constant as the load current goes up, we have the ability to make the output at the regulator rise to compensate for that drop. We have a pin, we call it CDC, cable drop compensation. And as the load current increases, the voltage at CDC goes negative. With no load, the voltage at the CDC pin is 400 millivolts, the same as the voltage at the bottom of the set resistor. So there's no current through the cable drop resistor. As the load current goes up, this point moves negative, pulling more current through our set resistor. And the increased current through the set resistor makes the output voltage rise. Since we have power good on this, we don't want to have the power good go out of regulation because we've got our cable drop compensation. So we tie another resistor from CDC over to power good, and that modifies the power good point so that it matches what the output voltage is doing. So we have a regulator that provides many different functions, including temperature current monitoring, power good, and cable drop compensation. If you want more information on the LT3086, please go to www.linear.com and look up the LT3086. Thank you.